we're going to use what we know about continuity to help us solve quadratic and rational inequalities. And I've broken this process down into 4 steps. These problems are a little bit longer, but if we break them down into bite-sized pieces, it's not going to be so bad. So the first example I want to look at is solving x squared minus 2x minus 8 is greater than 0. The first thing I want to do is I want to find all partition numbers of f. Partition numbers are places where f is equal to 0, so places where your function is equal to 0, and places where your function does not exist. So in this case right here, because if we look at this side, this is kind of our f of x here, x squared minus 2x minus 8, we said that's a polynomial, it's continuous everywhere, so we don't need to worry about the case where f does not exist. We just need to worry about the case where f is equal to 0. So I'm going to take this function, x squared minus 2x minus 8, and set it equal to 0. And we're going to solve this equation. So this factors really nicely. I can factor this to be x minus 4 times x plus 2 equals 0. I'm going to take each factor now and set it equal to 0. So we have x minus 4 equals 0 and x plus 2 equals 0. And then solving these two equations gives me x equals 4 and x equals negative 2. So these are my two partition numbers. These aren't my answers, but they're going to help me get to my answer. So that's the first part, is just finding your partition numbers. The second part here says we want to plot the partition numbers on a number line. So I'm just going to make a really rough number line here. And I'm going to take the two numbers that I found on there, which are negative 2 and positive 4, and put those on my number line. We're not going to do too much with this right away, but we're going to come back and work on it throughout the rest of the problem. Next step. This is kind of the most involved portion of the problem. It says choose a test number in each interval created in step 2 and evaluate f at each test number. Note whether f is positive or negative. So what I'm going to do is I've really created 3 separate intervals in this particular problem. I have negative infinity to negative 2. I have negative 2 to positive 4. And then I have positive 4 to positive infinity. So I really have these 3 separate pieces. I'm going to take a number in each one of these intervals, and then I'm going to plug it into my function, which is x squared minus 2x minus 8. Now, because we said, hey, this is greater than 0, I'm just paying attention to the sign of the number I get back. Is it positive or is it negative? Because if it's greater than 0, then I'm talking about positive numbers. And if it's less than 0, I'm talking about negative numbers. So let's start with the leftmost interval over here. We've got negative infinity to negative 2. You can pick whatever number that you want within that interval. So you can pick negative 3, you could pick negative 4, you could pick negative 5. I'm going to work with x equals negative 3. And actually, let me change my color here so that I am using a different color. I'm going to use x equals negative 3. I always like to use numbers close just because it makes the calculations easier in general. So I'm plugging it into x squared minus 2x minus 8. That's going to give me negative 3 squared minus 2 times negative 3 minus 8. So I'm just going to calculate this and find out what this gives me. So negative 3 squared, I should have a positive 9 plus 6 minus 8. So let's see, 9 plus 6, I should have 15 minus 8, I should have a positive 7. Now, it doesn't necessarily matter if you choose a different number than me, as long as that number comes from the same interval. If we had chosen, say, x equals negative 4, you might have gotten, well, I'll tell you, you would have gotten a different number than we got right here, which was 7. But the sign of that number should be the same. You can actually try that out for yourself. If you take x equals negative 4 or x equals negative 5, plug it into your function, you'll get back a different number, but that number should still be positive. So that's what we're really after, is the sign of that number. So we said We ended up with 7, which was positive. We're talking about this portion of our number line to the left of -2. So just to kind of make a note to myself, I'm going to put a little plus sign right there just to remind myself, hey, this is positive. So, okay, that's all I need to do for this interval. I'm going to repeat that process 2 more times. So next, I'm going to look at the middle portion. I've got -2 to +4. I always like to work with x equals 0 when it's possible, just because it makes the calculations a whole lot easier. So again, we're plugging that into x squared minus 2x minus 8. So here we'll have 0 squared minus 2 times 0 minus 8. 0 minus 0 minus 8 should give me -8. So it is a negative number this time around. So I'm going to put a negative sign above that interval so that I can remember what sign that had at the end of my problem. We've got one more interval to do. Now we're saying 4 to positive infinity, so we want to pick a number that is greater than 4. So how about 5? I'll take x equals 5 and plug this in. So, we will have 5 squared minus 2 times 5 minus 8. Here we have, let's see, 25 minus 10 minus 8. 25 minus 10, I should have, 15 there. 15 minus 8, I should end up with a positive 7 once again. Look at that. So it's a positive number, positive 7, so I'm going to put a little plus sign above that interval. And this now is really what I'm looking at. This is what I wanted to do in these first 3 steps here. This is actually going to tell me everything I need to know for the problem. All the heavy lifting of this problem is done. The hard parts, the calculations, this part is done. We can actually just, meant to highlight that. We can actually just read this number line here, and that's going to tell us our solution. So getting back to our directions here, step 4, that says create your sign chart, which we already have in this case, and then use it to solve the inequality. So I'm going to look back at the inequality that I was working with, and we had x squared minus 2x minus 8 is greater than 0. In particular, we said greater than 0. So if we're talking about numbers which are greater than 0, well, we've got 2 options. We've got positive numbers and we've got negative numbers. If we're talking about numbers which are greater than 0, we're talking about positive numbers. So that means the intervals which will be a part of our solution set are places where our function was positive. Well, we have that information right here. We said it was positive on -infinity to -2. And then from 4 to positive infinity. So these are the 2 intervals that I want to give as my solution. So if I'm talking about the answer to my problem, I'll put a little 4 right here, we would say my solution is -infinity to -2 union 4 to infinity. And I put parentheses around 4. I want to talk about that here in just a minute. We said strictly greater than 4. So if we think about how we came up with 4 and -2, we found both of those 2 numbers by taking our function and setting it equal to 0. So if we take those 2 numbers and again plug them into our function, we're going to get 0. We only want numbers which are greater than 0. We don't want greater than or equal to. So in this case, because we just want greater than, that means those numbers are not a part of our solution set, which means we're going to use parentheses around those 2 numbers. So these are a little bit longer of problems, but if you break this down into your 4 steps, I think it's a really nice process. I will say this idea, in particular, this idea of creating a number line and plugging in your test numbers, this is going to come back later on in the course. It's going to be really, really important for us once we get to Chapter 4, which I know seems like a million years away, but we'll be there before you know it. So make sure you practice these problems, because the more you practice these problems now, the easier those problems are going to be once we get to Chapter 4.